Now, let us discuss about some properties of this common devices. Greatest common device. Let D be the greatest common divisor of A and B. Suppose A and B are any two integers and D be the greatest common divisor of A and B. That means D greater than or equal to 0. If D divides A and D divides B, if E divides A and D divides B, then E divides D itself. These are the properties of this D. Now, the GCD of A and B is same as GCD of B and D. This is our first property. GCD of A and B is same as GCD of B and D. How? So let D is the GCD of A and B. D be the GCD of A and B. D be the GCD of A and B means there exists two integers x and y such that D can be expressed as a linear combination of this A and B. D equals Ax plus B. That means D equals Ax plus By means By plus Ax for all x comma y for n set. So that means D equals GCD of B and E. So clearly GCD of A and B is same as GCD of B and E. So this is the first property, which is the commutative property. Commutative property means for any two integers is A and B, then GCD of A and B is same as GCD of B and A. Okay. Now GCD of ACBC, or sorry, GCD of A and the next property is an interesting one. That is GCD of A and GCD of BC is same as GCD of AC and B. GCD of AC, GCD of AC and B. So this is an associative property. Associative property. This is an important property. If A, B, C are any three integers, then GCD of A and GCD of BC same as GCD of AC, A and C and B. How to prove this one? This can be proved by using this method. Let D equals GCD of A and GCD of BC. Okay. And GCD of AC and GCD of AC and B equals some E. Agree. Let D1 equals GCD of BC and E1 equals GCD of AC. Clear? Now listen, D equals GCD of A and BC. That means, this means D equals GCD of A and BC means D divides A, comma, D divides this GCD of BC. But what is GCD of BC? That is D1. So clearly D divides A and D divides D1. And GCD of B and GCD of AC is E. Means E divides GCD of AC. What is GCD of A and C? That is E1. And E divides B. Why? D be the GCD of AB. Then that means D divides A and D divides B. So according to that definition or that argument, D is the GCD of A and GCD of BC. So D divides A and D divides GCD of B and C. But GCD of B and C is D1. So D divides A and D divides D1. Similarly, E divides E1 and E divides E1. Yes, and sorry, not AC and B. It is AB and C. Sorry. AB and C. Sorry. D is GCD of ABC, AB and C. Sorry. So E divides E1 and E divides C. Agree. So this is the associative property. GCD of A and GCD of B and C is same as GCD of AB, A and B and C. So the D is GCD of this one, D is GCD of this one, then E is this one, and D1 is GCD of B and C, E1 is GCD of A and C, means E1 divides Yes, D divides A, D divides GCD of B and C means D1. E divides GCD of A and B is E1 and E divides C. Okay. But D divides D1. What is D1? D1 is the B and GCD of B and C. So means D divides B and D divides C. Why? Because D divides D1. So D divides D1 means D divides B and D divides C. Why? Because D1 is GCD of B and C. Now D divides A and D divides B. Here D divides A, D divides B. That means D divides, yes, it is AB, not AC. D divides here, D divides A, D divides B. So D divides A and D divides B means D divides GCD of AB. That means D divides E1. D divides E1. Okay, mark it as first result. Again, D divides C. There is D divides C. D divides C. Now E divides E1 and E divides C. D divides C and so D divides what is E? E divides E1, D divides C. So thus D divides C. Further D divides C. Therefore D divides both E1, GCD of E1 and C. Why? Because D divides C and then D divides E1 and C. That means D divides E itself. That implies D divides E. Now it is true. Further, E divides E1. Here E divides E1. Again E divides C. So E divides E1 and E divides C means E divides, what is E1? E1 is, so E divides A and E divides B, comma, and E divides C. So E divides B and that means E divides B and E divides C. So that implies E divides GCD of B and C. What is GCD of B and C? That is D1. So clearly E divides D1. So again E divides A and E divides D1. E divides A and E divides D1. That means E divides GCD of A and D1. What is E divides GCD of A and D1? That means E divides D. Mark it as 3. So combines these 2 and 3 means D divides C and E divides D implies D equals E. What is D? This is GCD of this one. And what is E? ECD of this one. Therefore D equals E means this holds the associative property. Agree. Now the next property of this GCD, greatest common divisor, is GCD of AC and BC. That's again an important property. GCD of AC, BC equals mod C into GCD of AB. So this property is called the distributive property. GCD of AC and BC. GCD of AC and BC is mod C into GCD of A and B. How? So far, its proof. Let D equals GCD of A and B, and the C equals, or E equals, not a C, there is a C element, so E equals GCD of AC and BC. Okay. D equals GCD of A and B means D be the common divisor of A and B. Then we have, there exists two integers x and y in X and Y. such that this D can be expressed as a linear combination of this A and B, that is D equals AX plus BY. Marking this equation 1. Okay. D equals AX plus BY means it is CD equals CA into X plus CB into Y, or AC into X plus BC into Y. But what is E? Again, listen, E equals GCD of AC and BC means there exist two integers X and Y such that E equals ACX plus BCY. Again, means E can be expressed as a linear combination of this AC and BC. So E equals ACX plus BCY, but CD equals EX plus CBY. That means CD equals E. That means CD divides this E. CD divides E. But what is 1? 1 can be written from 1. D equals AX plus BY. D equals AX plus BY. So means it is again CD equals, so CD divides C. Again D equals AX plus BY. So now listen, what is E? E equals ACX plus BCY, that is it is C into AX plus BY equals C. Why? Because AX plus BY equals D. So E equals ACX plus BCY, that means C equals C into AX plus BY, that is E equals CD. That means from here this E divides CD. Okay. CD divides E and C divides D. CD divides E means mod CD less than or equals mod E. C divides mod CD means, E divides mod CD means mod E less than or equals mod CD. So combines you have E mod E equals mod CD. Okay. So that equals mod C into D, means E equals mod C into E equals mod C into D. What is E? Why? Because E is the divisor. Therefore, this E greater than or equals 0. Therefore, E equals mod C into D. What is E? E means GCD of AC and BC equals mod C into, what is D? D is GCD of A and B. Thus, GCD of AC and BC is same as mod C into GCD of A and B. Agreed. So, this is our recap.